may I say, just as folks come in, and before I give you a proper introduction, that you are very persuasive, and it's making me sad. my official Star Trek membership pin is now decreasing in value.
Yeah, I also feel that it could make us feel special about ourselves, and it really gives us a sense of responsibility. We're facing a complete unknown there, but also opportunity.
Yeah.
I mean, if the galaxy is teeming with life forms, therefore biochemistries that are so different from our biochemistry, but yet no intelligences to sort of rule over all these worlds, it's up for grabs.
Yeah.
It's up for grabs. There are lots of safaris to be had.
Excellent. All right. Well, we have a small but eager audience here, so let's not delay much longer. I want to welcome everyone to Alone in the Milky Way question and answer session with Dr. Pascal Lee. My name is Tucker Hyatt. I'm the founding director of Wonderfest, the Bay Area Beacon of Science, and a key supporter of the Mount Tam Astronomy program, which has brought us this event tonight. The two people most responsible for tonight's glory, besides Pascal Lee, are Tinka Ross, the founder of the Mount Tam Astronomy program, who is joining us on video right now, and John Navas, the Mount Tam online engineer. Thank you both, Tinka and John, so much.
Thank you. Good to see you.
In just a moment, I'll describe how to go about asking questions of Pascal, but let me give him a proper introduction first. Dr. Pascal Lee is a planetary scientist at the Mars Institute and the SETI Institute. He is internationally recognized for his work on the history of water on Mars, on the origin of Mars's moons, and on the future human exploration of Mars. In short, Pascal is as close to being a Martian as anyone I know. Pascal earned a bachelor's degree in physics and a master's degree in geology and geophysics from the University of Paris. After coming to the US, he earned a PhD in astronomy from Cornell University, where he worked with Wonderfest inspiration and my personal hero, Carl Sagan. In fact, Pascal, please correct me if I'm wrong, but you were Carl Sagan's last teaching assistant.
Yeah, last TA.
So we are going to be even better taught than we were in that video by enjoying a question and answer session with Pascal now. Let's do this. Let me ask you first to first make sure to stay muted until you have a question, and then unmute yourself and remute yourself afterwards. By the way, to find the mute and unmute key, the emblem, move your cursor down toward the bottom of the window, of the Meet window. And you'll see a white bar arise with 3 emblems right in the middle. One is the microphone emblem, and one is the video emblem. Don't hit the video emblem, and certainly don't hit the middle emblem with the red phone. That is the detonate button. That is the close this Meet experience button. So let's just deal with the microphone button, please. But also to at upper right, I think you'll see let me make sure here. At upper right, I believe you'll see a little emblem representing not the number of people currently attending, but rather a little thought balloon, or an emblem representing a spoken dialogue. When you click on that, the chat window will open to the right of your Meet window. And there is where you can type your question, or you can see the history of other questions. And we can engage both in written communication with Pascal and with verbal communication via your microphone, and perhaps a raised hand. If you want to let us know that you'd like to ask a question, please raise your hand the old-fashioned way by waving it near your face in the video. All right, we already see a question here from Chien. Pascal, what's the probability other intelligent civilizations have detected our existence?
Yeah, no, that's a very good question. I think that if you are another intelligent civilization, say in our galaxy, and you had the means, with a super telescope to study exoplanets around other stars, you could tell that the Earth has life because we have an oxygen-rich atmosphere, and it's becoming more and more clear that if a planet has an oxygen-rich atmosphere, it's not a stable situation. Oxygen is a very oxidizing oxidant. It's very reactive. It's not going to just sit there in an atmosphere unless it's produced actively. And so detecting an oxygen-rich atmosphere, which you could imagine other civilizations, if they were in our galaxy, could do with telescopes that are similar to ours, if they were not too far away, and are into detecting exoplanets, they would know that there is life on Earth. Now, signs of our own intelligence, in other words, signs of human beings roaming the Earth, that is not something that would have left a signature that's detectable by other civilizations. I mean, unless they came visit remotely, they would not be able to detect us. And in fact, the only time I think where we would have started to sort of send signals of our own presence is when with the advent of loud radio broadcasts, powerful radio broadcasts. So this really started in the 1930s, and several people have recognized that one of the most powerful, some of the earliest powerful broadcasts were Hitler's Hitler's rallies and his speeches. And so right now, as we speak, racing across the galaxy in this expanding front of radio transmission coming from the Earth, when we sort of became radio loud, if anybody could detect that, the first impression we would give would be Hitler's speeches to another civilization. So it's not a very good start if you wanted to leave a first impression. But sort of this little quirk aside, we would only, another civilization would be able to detect us only if it were within about 100 light years from the Earth. That's how far our radio loudness has reached at this point since the 1930s. I mean, I said 80 to 90 years, that's about it. It's only until 2030s that we will have reached an expanding front of about 100 light years. So that's not far away. And I'm pretty sure that there's no civilization within 100 light years. I mean, there's a lot of uncertainty within, but, I'd be very surprised. And so nobody knows about us is sort of the answer to this question.
Thank you, Chien.
Probably.
Perhaps you can see Pascal Akash's question. If there is another civilization out there, how do we communicate with them if they are, say, 50,000 light years away?
Yeah, very difficult. They would not have heard of us. We might hear them if they have been broadcasting for over 50,000 years, because at which point their radio noise would have reached us. Now, that assumes that, well, first of all, it assumes that they would have been broadcasting to us 50,000 years ago. They might not even be around anymore. If it is true that the average longevity of a civilization is only 10,000 years, then what we would be detecting from them, their radio loudness would have been that spike in their presence in the sort of cosmic history of the galaxy. It's sort of, civilizations might be like lights on a Christmas tree. They sort of come on and then they go off, and that's so if they don't last very long, that is. So a civilization that we would be detecting that's 50,000 light years away from us might not even be around anymore, is sort of what I'm trying to get at. But of course, so far nothing has been detected.
Thank you, Akash. We'll come back to one of your other questions here, but I see that Brayton Fisher has a question.
Speakers.
Okay, let's see. Suppose civilizations communicate in a different manner, like quantum entanglement. In that case, SETI is monitoring obsolete electromagnetic technology that is only temporarily used.
Yes, that's a good point. In fact, that point was sort of, I think, captured in my comment as I ran down the excuses for the Fermi paradox. If there are civilizations out there, why aren't we detecting them? Or one reason could be that it's lost in translation. Okay, so in other words, they are using some means of communication that is just not what we're expecting, or that we haven't matured to yet. And so we could be missing them completely because of that. So I think that's your point, and I think it's a very good point. And indeed, electromagnetic technology could be obsolete. I mean, we feel that it's, state of the art, but of course, so did the people who invented the steam engine.
How about this other question from Akash? I have a feeling this will appeal to you, Pascal, because of your own research in future Martian exploration. Akash's second part of his first question is, if there is a habitable planet devoid of life, how do we colonize it?
Yeah, that's interesting. So if it's habitable, I think one thing we should try to find out is if it is already inhabited, not necessarily by a civilization, but by an ecology. And we suspect that if we do find alien life on a planet, and again, we're not talking about intelligence here, just some alien form of life on a planet, it's not just going to be one life form. Life, the way at least we understand it, needs, builds ecologies, needs biospheres. It's a sort of a complex ecosystem. So let's say we have a habitable planet that, in fact, we could sort of move into relatively readily, but it is already occupied by life forms. We really would want to study that life form, okay? Because, I mean, for example, all life on Earth uses the same subset of amino acids that are possible in nature. There are thousands of amino acids that are possible in nature. All life on Earth, you, me, the squirrels, my dogs, we all use only the same 23 amino acids. And the amino acids are the building blocks of protein. So all the protein that we eat in meat, food, vegetables, it's all some combination of the same 23 amino acids. There's no particular reason why it's those 23. We just think that that's something that's inherited from our common ancestor way back when, that was microbial. But it's not just these 23 amino acids, it's the fact that we are only using the left-handed geometry 23 amino acids, because there's the mirror image of each one of these molecules, the right-handed version of it. These are called sort of enantiomorphs in the biochemical jargon. So we only use, in other words, we only use one, the left-handed version of all these amino acids. Now, let's say you run into a planet that is suitable for life. In other words, it has an oxygen atmosphere, it has enough atmospheric pressure, but it has life in it that that somehow uses a different set of amino acids, or even the right-handed ones. We might want to figure out what that could do to us. I mean, is that going to kill us? Is that going to, can we process that food that we would grow there? I mean, there are lots of questions about these alien ecologies that have to be worked out that we right now would not know. So habitability from the standpoint of just physical conditions is one good news, but then we'd have to figure out who's habiting that place already and whether or not we'd be compatible to move in. And then, of course, you have the ethics of whether or not we should move in. That's a longer discussion. I mean, I think the long and short of it is that if there's an imperative for us to survive, we are justified to move in because that's what nature and life does. if there's no imperative for us to survive, to sort of conquer that planet, we might want to apply the prime directive, which is to let them evolve on their own and not disturb them.
Thank you. We have a live question from Jill Lilienthal. Please unmute yourself, Jim, and let us have it.
Yeah, okay, here I am. I had to write it that way. My keyboard went out last night, and I cannot type the letter A, so I had to figure out a way to get in here without that. Okay, I have just intuitively been disposed to have the same sense that Dr. Pascal has for a while, and I'm curious about whether within SETI he is the Drake equation solution for one, and therefore the only SETI member who puts the probability that low. And if not, what the main disputes with your calculations are.
Yeah. I mean, clearly n equals 1 is not the most popular view at the SETI Institute. But, the SETI Institute is an amazing organization. And I should, probably throw in a pitch for the SETI Institute because it's very well deserved. They're very open-minded. It's all good. It's all good. It's an open scientific organization that argues the pros and cons of, and the possibilities of life out there. Nobody has the answer anyway. So n equals 1 is certainly a number to consider. It's part of the trade space. First of all, I think that given the error bars that exist around the argument, it will be the first one to recognize that the SETI search within our galaxy is still worth doing. I mean, considering how little resources is actually put towards this compared to what potentially is at stake, we ought to search for intelligent civilizations within our galaxy and among nearby stars, regardless, just because we really have just begun to this search. And at the end of the day, we really don't know. I mean, with just the Earth being the one example, we could be an unrepresentative example of how life proceeded in our galaxy. But the other thing is, I'm working on this paper with a student of mine where the premise is like this. Let's say n is equal to 1. How would you then go about your SETI search? And the answer is you go to extragalactic SETI searches. In other words, now you're looking not at our own galaxy per se. What you're going to do is you're going to try to see if you can detect an intelligent civilization or the technosignature of an intelligent civilization, one galaxy at a time. So maybe your chances there are going to be greater. Now, of course, it's much harder. And then, of course, even if we saw a signal coming from, say, one galaxy that we could pinpoint, which is difficult because galaxies are so tiny, most of them, they're so far away. So we're talking about maybe focusing on the nearby galaxies first as a start, and then expanding to further galaxies. So let's say the Andromeda Galaxy. The Andromeda Galaxy has 1 trillion stars. So it's anywhere from 5 to 10 times more stars than our own galaxy, if that's the case. And therefore, it might have 10 trillion planets. Okay, and therefore it might have 10 civilizations. Compared to ours. Well, if that's the case, can we, and this is sort of at this time, so to speak, at any given time, there could be 10 civilizations. So, might any one of them be loud enough to be heard, seen, or, shine a laser beam at us, even inadvertently? So I would advocate a SETI search strategy that would, for example, monitor the Andromeda Galaxy at all times, 24/7, at all wavelengths, radar, optical, laser, just to capture any even transient event of radiation, meaning electromagnetic radiation coming from that galaxy. I mean, to me, that would be because now you're searching 1 trillion or 10 trillion planets at a time. If you did that, So that increases your odds considerably of finding something. And to me, that, and of course you would have no prospect of ever communicating with them, because for one thing, the Andromeda Galaxy is 2.5 million light years away. So any one of those 10 civilizations that you would see now, which is sort of your given time, could have long passed. But who knows? If one of them achieved multi-million year duration, they could still be around. In fact, they could be making a lot of noise in the Andromeda Galaxy. So searches for things like the Andromeda Galaxy have been done before in SETI searches, but very fleetingly, just as in, let's check out what's coming from M33, M31, which is Andromeda, and M33, which is another large galaxy within our local group. And nothing was found so far. But we should, I think that's, to me, that's where we should focus our SETI effort, or at least add a dimension to the SETI effort, which is a systematic search of nearby galaxies. I think you're muted, Tucker.
Thank you. Pardon me. Jim, I just wanted to remind you to do what I needed to run myself to undo, which is to unmute. Thank you, Jim. All right, Pascal, I see another question here, a follow-up question from Chien. She asks, is there an equation similar to Drake's equation that estimates probability that other intelligent civilizations might detect our existence? Kind of a reverse Drake equation.
Yeah, I mean, well, first of all, the Drake equation, like I pointed out in the cartoon, could be universal enough that another civilization might have come up with it, and could be applying it to sort of organize its search. But I'm not aware of any particular equation similar to the Drake equation that's about detecting us specifically. But again, I think any other intelligence out there, this could be very, I could be throwing a big anthropocentric bias in this statement, but I'm guessing that what is sort of speculated about in the Drake equation is basic and universal enough and simple enough mathematically that another intelligent civilization that's capable of radio communications would have come up with something like it. It just makes sense.
Yeah. I notice another question here from Akash that I think deserves your attention here. It asks, if life is a common product of chemistry, why is intelligent life so uncommon? Now, you did address that, but in particular, it does seem that there is survival value, Darwinian survival value to intelligence, yet it did take a very long time to arise. Would you care to comment on that?
Yeah, so so the observation is that life appeared early, but intelligence showed up really late. To me, the immediate implication is that intelligence is not that critical. It's just not an imperative as much as other things about life for life to come up with in order to survive. I mean, it's not like we at different stages of the evolution of life on Earth got close to being technological and then somehow, it went away. We never came close to this. And in fact, once we got to very large animals at the surface of the Earth, in the Jurassic, the Permian, and for Permian onwards, Jurassic, Cretaceous, reptiles and dinosaurs ruled the Earth for almost 300 million years. 300 million years. Bearing in mind that it's only about 550 million years ago that the Cambrian explosion happened. So where, big slug-like life forms started to proliferate in a big way. In this 500 million year span, dinosaurs, reptiles ruled the Earth, the surface, the largest creatures for 350 million years or so. And at no point, and they were bigger than we were. They had big brains. At no point did life have the imperative to come up with something that could, build a city or, a flashlight. And that only happened. I somehow went into sleep mode here on my computer. I'm not sure if you hear me. Do you hear me still?
Pascal, we do hear you. Just keep rolling.
Yeah. Okay. So, so I think the way intelligence seems to have appeared on the Earth, if we define intelligence as being something as capable as Homo erectus, was really as a result of this giant impact that wiped out the dinosaurs. All of a sudden, what was roughly 350 million years of rule by, the survival of the strongest, just got completely reset. I mean, the dinosaurs were out of the way, and then meanwhile, mammals who had been around for a long time, for tens of millions of years as well, mammals all of a sudden, at the time, were mostly burrowing mammals. All of a sudden, the path was clear. The dinosaurs were gone. The nasty birds were gone as well, most of them. And all of a sudden, mammals could conquer the land. So that was just really an opportunistic thing. And then even then, that was 66 million years ago. It's only in the last million years that something like a standing ape, emerged. And it looks like it might have been just due to particular imperatives of the climate drying up in a particular region where there were primates, and where these primates could then somehow continue to eke a living by becoming bipedal, because they were sort of in a transition. Their forest transitioned to a steppe-like setting, where with tall grass they had to stand to see what was over the horizon. And once they started standing and running on 2 feet, they that freed up their hands to do other things with their hands. So it seems like it's largely fortuitous. So for sure, intelligence eventually provided an edge, and it's sure enough, it's what allowed us to conquer the Earth and become the dominant species. But it's not like life had all along the plan that one day intelligence shall arise, and we're sort of aiming for it. It just was not that much of an edge for most of the time that life was on Earth.
We're getting close to our approximate end time here. I urge those of you who haven't asked a question yet to please speak up. I see a question here from Brayton Fisher, a second one from him. Advanced civilizations may consider us too dangerous to contact, or even to be aware of, or even let us be aware of them. Shouldn't this fear factor be part of the Drake equation?
Sure. And in fact, what we're talking about when we say that we are the number of advanced civilizations, if you notice the fine print, even in my talk, it's advanced civilizations capable of interstellar communication. It doesn't mean that they actually engage in it. It just means that they have reached a point where they are capable of doing it. They could communicate with us, but of course, as part of one of the excuses of the Fermi paradox, they could choose not to. So that's actually included in the definition that we have of the Drake equation right now. We're just counting the numbers of those who could communicate, not necessarily the number of those who would communicate.
Pascal, let me sneak a question in here. Since your work with your student, last name Morrill, involves trying to detect signals from entire galaxies, and since we understand now the basis of that argument, I think, have you had luck with persuading other folks at the SETI Institute to try training their telescopes for prolonged periods on entire galaxies?
Well, I should point out that there have been over the years occasional, and there's even an ongoing effort here to try to listen to extragalactic searches. It's just that it's not mainstream. So we're hoping that our paper will establish the fact that it ought to be part of the mainstream, because as remote a possibility it is to communicate at all with an extragalactic civilization, we actually have a greater chance of finding one, of hearing of one. So we want to get that paper out first, and then we'll have more discussion. But I really don't want to leave anybody with the impression that the SETI Institute is somehow offended by this. It's a really an amazing organization, which incidentally you should support if you can or wish to. It really is an amazing organization, and here we are asking these fundamental questions, and we have the luxury of not only asking these questions but exchanging ideas that are not necessarily in the interest of the organization itself, in the sense that if there's actually no civilization to be detected, then what are we doing here at SETI Institute? Well, we're doing a lot of other things. First of all, we study life, the possibility of life anywhere in the universe, including in planets. The vast majority of the research that's being done at the SETI Institute is actually done in solar system research and exoplanets. So not in direct SETI listening or searches. Okay, it's just one component of what we do.
Thanks, Pascal. You're already getting some thanks in the chat bar. I imagine every one of us might like to offer an inaudible visual clapping for your presentation tonight, both the video and your bravery during Q&A. Thank you. I want to remind the audience that this program is brought to you by the Mount Tam Astronomy Program, and the program will reconvene in the coming year in 2021, starting on April 10th. You'll want to tune in to mounttamastronomy.org to find out what that first program will be of the new year. Keep an eye on mounttamastronomy.org even throughout the winter. And now, Pascal, I want to thank you. I want to thank Tinka Ross for creating the Mount Tam Astronomy Program, and of course, our online engineer, John Navas. A big final round of applause. Thank you all.
Yeah, thank you.
Attendees.
A really big thank you to you, Tucker, John, Tinka, San Francisco amateur astronomers as well. Thank you so much for having me.
You bet.
Pascal, you were a pleasure to work with, and it was an outstanding program. Thank you so much. And Tinka, do you have any closing thoughts? This is kind of our swan song for the year.
Thank you, John. I don't know. I think that this has been a very difficult year. We've made the transition as best we can doing online, but I really can't wait until we get back up on the mountain and have our live presentations followed by the observing. I feel very badly for the San Francisco amateurs because we've been able to go forward with our programs as far as finding these excellent speakers. Thank you for that, Tucker. And getting out information to the public. But the amateurs have actually been dark. And I'm hoping that we'll be able to get back again, because our whole program intent is to give people two ways of doing astronomy. One is the intellectual, the learning and understanding of some of the things going on, particularly in new things that are happening in the field. But secondly is to do that visceral feeling and experience of going out and actually observing and seeing the wonder of the world and the universe and its grandness. So we had a tough year, but I think we're going to look forward, and hopefully we come back next April online, live, but we'll see what goes on. Thank you so much, and thank you so much to Tucker and to John for really keeping this program together this year. Thank you, Pascal. This is an excellent program that we've really enjoyed, and it's interesting to find an astronomer who has sort of a different point of view on something than what we think is what is accepted by most astronomers, and being able to give us all the reasons for it so explicitly. So thank you so much, and thank you for all of the people who have joined us and who have supported us through this year. Let's all keep well. Good night.
Thank you.
Good night, everybody. These programs are produced by Mount Tam Astronomy in collaboration with the Friends of Mount Tam, with the San Francisco Amateur Astronomers, and with Wonderfest, the Bay Area beacon of science. The programs are free and open to all. Mount Tam Astronomy is organized by Tinka Ross, and this video was produced by John Navas. To attend a live program followed by live telescope viewing of the night sky, or for a list of upcoming Astronomy Nights programs, visit our website at mounttamastronomy.org. For Mount Tam Astronomy, I'm Tucker Hyatt.